All right, thanks everybody for coming out after lunch on the last day of KubeCon. Selfie, oh, wow. Actually, maybe at the end because we've got a lot to get through and I don't know if we can pull it off, but so no intro, you heard who I am. What I want to do is give you a very, very quick whirlwind tour of why we are where we are. Who's been in this room before lunch at either of the two presentations? Yeah, not enough. So we have to go through this because actually both prior speakers did a great job of kind of walking through where we are. But really, the OCI, Open Container Initiative, has brought us to this place where we have multiple OCI compliant runtimes. We have compliant registries. The distribution spec is being worked on this year in the OCI, and so we have this set of runtimes, which is both great in one sense, but also can be confusing. You know, what do I use? Why do I make these choices? And so the idea for this talk was to give you, again, a very, very fast-paced kind of walk through all your options. I can't tell you what to choose, but hopefully, maybe through the work I did to try and get this all set up and working, it may give you some insights as far as, you know, why various runtimes exist, why they've been created. And really, following the OCI, Kubernetes said, hey, this is going to be crazy trying to support all these runtimes in the code base. We need an interface where we abstract this. CRI is the container runtime interface in Kubernetes. Again, there's implementation details behind that, lots more great talks that you can find online. Just briefly, obviously the runtime has certain responsibilities that really are around the pod lifecycle itself. Starting pods, stopping pods, status, pulling images, do I have this image, where are the logs, give me, exec me a process. Everything else is handled by Kubernetes, all the orchestration. Of course, this picture is even, not quite correct because there's other little sub pieces, whether we're talking about CNI or CSI for storage, but again, that's all outside of the runtime's purview. So this is a picture I've shown in multiple talks. It's almost up to date, it's almost correct. But again, this is kind of the suite of runtimes that we'll look at today, all the way from Docker through Containerd, Creo, and then what a lot of people call the sandbox VMs, or sandbox concepts, which includes VMMs and gvisor and others. And then at the very end, we'll talk about Singularity, which is a high-performance computing academic runtime, which also has a CRI now, and we'll look at that briefly as well. Here's the caveats. I don't have time to do possibly everything, including I'm not doing Windows, which has runtimes as well. I'm not doing Rocket, which of course is a CNCF project, but again, I don't have that set up. And then Virtual Kubelet actually implements the CRI as well. But isn't necessarily in the realm of container runtimes. Nabla, I'm going to talk about briefly as long as we have time, but I didn't actually have time to set up a demo. So those are the things you won't see, but are in the sort of related area of runtimes. And then, when you write your CFP, you have this grand idea that this is going to be amazing. I'm going to create this super cluster, all these nodes, different runtimes in the same cluster. If you ever search the nailed it fails, this is an example. You're going to take this amazing picture you saw somewhere, but in reality, it's a lot messier. So that's what you're going to see today. I have multiple clusters. I've got GKE to show, two-node cluster to show Docker. Again, not that exciting. We've been using Docker as a Kubernetes runtime for a very long time. But again, just to fulfill my promise, we've got Docker. I've got an IBM Kubernetes service 3-node Containerd cluster. But then I thought about hacking that up to try and do some of the other interesting sandbox implementations. But I need bare metal to access dev KVM for the VMMs. So I grabbed a bare metal instance, and I have Containerd, and that's where I'll show Firecracker. That's where I'll show Kata and gvisor. I have another single node VM with Creo. I used kubeADM to install that. And then someone in IBM Cloud said, hey, I've been messing around with the with the community version of OpenShift. So I've got a 3-node cluster, so I also have that with Creo. So these are the pieces I'll be showing to give you kind of that quick demo of each runtime, and then at the end of each, I'll kind of give you, there'll be a slide with a lot of words on it. I'll probably try not to read all the words. I will share it online so you can easily reference that after the talk. So first, obviously, as I said, Docker, since the beginning of the Kubernetes project, has been that default runtime that handles this pod lifecycle for your containers that get created and started. Again, I said I would demo all of them, so if I go here and show you this GKE cluster, we should see 2 nodes, as I said. At the very end, I know this is messy. I tried to make the font big enough. Is this going to work for those in the back? Partially. I can even make it bigger. So at the very end of this wrapped line, which is a little messy, you see Docker 18.9.3. So again, GKE, by default, when you create a Kubernetes cluster, you end up with Docker Engine. You can also, during that GKE process of creating a cluster, you can pick the containerd image, and you can actually use containerd. And I don't speak for Google, but I believe they will be maybe moving fully to containerd in the near future, like we do in IKS at this point. We can obviously deploy a simple, Nginx YAML and see that, we have pods running Nginx. We know they're running on the Docker engine. I'm not going to access the worker nodes and prove that, but I'm sure you believe me on that. So again, this is the most common original runtime for Kubernetes. Actually, one of the benefits, it simplifies tooling. So if you have tools that kind of cheated and knew that there was a Docker engine on your worker node, is that happening regularly? Are we losing? There we go. Got a little bit of a cable mess up here. So again, Docker being on that worker node makes it simpler for tools that maybe run outside of the Kubernetes infrastructure and just use, Docker commands. And again, as people have migrated away from Docker to other CRI implementations, that's definitely been an interesting challenge to find that, basically some tools need to be reworked to not expect the Docker engine or the Docker API socket. Definitely, in some sense, it's more than enough engine for Kubernetes. There was a talk here just before lunch about a company migrating to containerd and making the comment that it's really more than what we needed. And then over time, and what really brought about some of the other CRI implementations were these concerns over Docker's lifecycle, versioning, and Kubernetes, and kind of the synchronization between that, and which engine version would actually work with which Kubernetes version. And obviously, because the Docker engine has more capabilities and components, extra memory and CPU use. Containerd, so again, this is the project where I'm a maintainer. We have several other maintainers here in the room. And if you're interested in a lot more detail about Containerd, the deep dive session is this afternoon, I think 3:55 in room E4, but it's on Sched. You can find it and easily go to that. So if you want to hear a lot more about Containerd's architecture, how it's used, you can go to that session. Again, I will demo using again, this is my IKS 3-node cluster. So again, if I make that font size a little bit larger, you can see here, again, at the end of the wrap line, Containerd 1.2.6 is the version that I'm using in this cluster. And again, we can deploy our same exact YAML. And again, the value of the OCI here is that I don't have different images when I ran on GK's Docker-backed cluster. And so I don't have a different image here. And so obviously, if I look at these pods, you know, they're up and running, they're using containerd. I could log into the worker nodes and prove that to you, and actually, for the next several, when we look at the sandbox VMs or VMMs and other isolation techniques, we'll actually have access to the command line of the host, and we can validate what's actually running. But again, suffice it to say, Docker containerd, very straightforward to run that. So again, containerD's kind of current status, GKE, you've got it in beta. You can select it when you create a cluster. IBM's IKS service has moved fully to containerd, so all new clusters that get created use containerd as the runtime. Alibaba Cloud is also using containerd significantly across their platform. Interestingly, every Docker installation also includes containerd. So in a sense, every public cloud that's using Docker is also using containerd, and by nature of that, we get lots and lots of testing on the platform. You know, even those millions of developers who install Docker Desktop, that's also using containerd. Obviously, a value of containerd being smaller is that you have memory CPU usage, and it's also got a really nice clean API, which again, you could hear more about if you go to the deep dive. It's obviously without the Docker tooling and API socket, you have this migration complexity for plugins and tools. So IBM, we've worked with a lot of our partners in IBM Cloud. So you may have seen announcements, Sysdig supports containerd, or Sysdig supports cri-o. All these tools, Twistlock, Aqua, and others have had to make this migration off dependence on the Docker API or the Docker tooling. And again, other things are in flight, but again, we should move on to Creo. So Creo, as I said, I've got a couple setups. So let's look at this one. I have here, I have a VM, and I tweeted this the other day just to be goofy, but my VM was originally for containerd, and so its host name is containerd, but it's running Creo. So that's just your container runtime joke for the day. So again, I'm running, again, a single node cluster I brought up with kubeadm. I also have access to that cluster I mentioned. And yeah, here you can see the output of that. It's running, again, the OKD, the community distribution, also running Creo 1.11. So again, it's a little bit older than my kubeadm up cluster here. So again, we can do the same Nginx example and see that we should have some Nginx pods, again, running here. Now this, I'm actually on the node that's running, so again, a single node cluster, I'm on the node itself, and so we should be able to see, what we can actually see are all these conmon processes from containerd handling the actual connection to the containers themselves, and we can also see the Creo daemon running. Actually, now that we have containers running, we'd have to scroll back. But again, based on time, I think it's clear that Creo is running these pods, and that the Creo engine is the CRI configured runtime for this single node cluster. Again, Creo is used in OpenShift. SUSE uses it in their container as a service platform. There are other customers and uses of Creo. I believe there's an end user in the CNCF community who has mentioned that they're using Creo as well. Again, the Creo team has promoted it as all the runtime Kubernetes needs and nothing more, and has this idea of kind of separation of concerns. So instead of all the pieces being in a single engine, there's Podman, there's Builda, Scopio, and so they all work together on the same back end. Now, again, because it's meant primarily for Kubernetes, so again, it doesn't have necessarily tools of its own like a client, so you use the other tools as a design choice. I found that use and installation of it, unlike Ubuntu, just because that VM was Ubuntu, can be complicated. Again, the team is aware of that. There's some issues open, and that's being solved. And again, a design choice is that, unlike container, which has the API and the extensibility, it's really, again, meant to be for Kubernetes. And so there is a proposal from Kata to add the Shim API to, again, make Creo similar to Containerd with extensibility around adding some of the sandbox implementations. So from here, we're going to talk only about several sandbox implementations, and we're also going to use runtime class as a way to execute a few of those. So this came around in Kubernetes 1.12. Prior to this, there was a notion in the pod spec of an untrusted runtime. So if you had a workload that you wanted a higher level of isolation on, you could basically say this is an untrusted workload, and then the way you would set up your cluster is that you either use Kata or one of the other sandboxes as the implementation of that untrusted runtime. Runtime class brought more flexibility in that you could add multiple runtimes with a name and a handler, and so at that point you could then begin to basically specify in a pod, this pod should work under this runtime, use this runtime handler to create and start this pod. And so that's what we're going to show here. In a minute, before I did that, I thought this picture from the Kata folks was helpful, that, again, why we added the v2 Shim API. In a sense, many of these sandboxes were seen as just run C replacements. So again, all these runtimes are using the OCI runtime at the bottom. And so one easy way to add functionality, like wrap it in a VM, was to replace run C. And that required sort of a complicated set of other shims and proxies around it. With Containerd's Shim API, that could be simplified, that you could basically put all that in the Shim implementation for your runtime, which again, in this case, Kata could then have that direct link to their agent to talk to inside the VM. And again, so this simplified the picture. And so now you'll see in a minute, we have many shims available for Containerd to run the various sandboxes. So the first one I will show is Kata. And so I think just based on what I just said, I think the first thing that would be maybe interesting to show you is that I've installed a set of shims that includes AWS Firecracker. It includes the standard V1 and V2 Run C shims. It includes Run SC, which is for gvisor, and also the Kata shim as well. So again, on this node where I have a single node cluster, Containerd is the runtime, but Containerd can drive these other shims by either specifying it in the Containerd client or by using runtime class, which is what we're going to do. So again, to just show you what we have here, again, this is a bare metal instance, so it has the ability, again, you could use nested virtualization if that's available in your IaaS. In my case, I'm using a bare metal instance, so I can run KVM. So I've got Containerd, and the version number is kind of messy because I'm running off master, and so this is basically 126 plus, which I needed for some of the fixes that had to be available for doing some of the demos. But again, Kubernetes 1.14.2. So the first thing I'm going to do, first, obviously, it's Containerd. So if I don't specify a runtime class, then Containerd is actually going to run that container. And we should be able to see that if I use the CTR client. I won't see it if I just ask Containerd for a list of containers, because Containerd is namespaced. And so Containerd on this particular node is being shared by Docker and Kubernetes and whatever other uses I might want. So if I do namespaces ls, you can see there's 3 namespaces. I'll put that up top. default k8s.io and Moby. So Moby is Docker's namespace, k8s.io is Kubernetes, obviously. So now if I say in that namespace what's running, well, I'm running a Kubernetes. Is it coming and going? I'm sorry about that. I don't know what the HDMI doesn't like this. So as I said, there's many things running because although I do have the Nginx pod I just started here, there's also the Kubernetes, again, a single node cluster. I've got the API server running, core DNS, et cetera. So you can see all those containers. At this point, I will register the runtime classes. And so we can look at one of them. So the runtime class for gvisor, for example, very simple YAML. I'm creating a runtime class. The name is gvisor, and the handler, and this is in containerd's config, it's called runsc. And so this will allow me to start a pod using gvisor. So let's do that. Actually, no, I said I was going to do Kata first. I'm getting ahead of myself. So I've registered the runtime classes, and now I have an Nginx example for Kata, and so all I've done here is change that initial pod spec to add the runtime class, and I've said I want to use Kata for this deployment, and we can look at that briefly just so you can see that. So, all right. Is this happening like every second it's coming and going, or? Intermittent.
Just maybe like try not to touch it as much as possible when you're typing.
Yeah. All right. So runtime class name here says Kata. And so now we've deployed that, and so we should be able to see that if I go to containerd, actually, of course, that didn't work because I already had, deployed with the same name the other pod. So let's do that. Now the Wi-Fi is making my typing slow. So we don't have the Nginx running from containerd anymore. So now let's try and deploy this. So this is fun with heavy demo. All right, so we have a Nginx pod running. We said to run it with Kata, so we should see that Kata is involved in this. And so we see a bunch of shims running. And I'm not seeing my Kata shim. Let's exec into that. Yep, sorry. I'm trying not to touch. So if I do dmessage in the container, this would never happen if we were using simple Linux containerization, but we've seen we've actually booted a kernel. And so this is hopefully our proof that we've run Kata. Again, there was a great talk in here at the beginning of this session on Kata that has the history of coming from Intel Clear containers and the hyper.sh project. It uses KVM QEMU-based isolation. They do work with Docker, Creo, and Containerd. And so again, they're part of the OpenStack Foundation. It's a growing project. And recently, they've actually added the ability to use Kata, but also to choose between the QEMU KVM or the Firecracker Rust-based VMM. And so again, you could use Kata to drive either Firecracker or the Kata isolation. For Kata-based isolation, they support quite a few architectures, including ARM, including IBM's P and Z series. And so again, this is an interesting project with a lot of activity. And again, there's a lot more information online. Firecracker is a much younger project. So I have the runtime class installed, but Firecracker requires a different snapshotter for Containerd. And so to simply show it running, I'm actually just going to run a Firecracker container with the Containerd client rather than through the CRI, because the snapshotter it's going to use by default with the CRI is not the one for Firecracker, and so that won't work very well. So if our screen stays, I'm just going to do ctr run fc. This is doing, I'll show you the command in a minute. It's using Containerd's CTR client, and it's running, it's basically specifying the snapshotter and the runtime. And so here I'm at a prompt, and again, I see that I've booted an actual kernel, again, because Firecracker has done that in the background. I have my snapshotter running, and it's set up the BusyBox root file system and provided that to Firecracker. And again, other than that, it looks like a standard container. This is BusyBox. So again, this is Firecracker. Again, as I said, it's a fairly young project. It's got a Rust-based VMM that originated from Google's Cross VM project. This was open sourced by Amazon just late last year. It's a young project. It tightens down both kernel access with its jailer. And then it, again, integrates with Containerd via the shim that we just saw. Getting it packaged and delivered, this was fairly complicated. You have to set up a root file system. You have to put the agent inside of it. So there's a lot of kind of manual steps. So I think as this project matures, there'll be better, kind of cleaner delivery of how can I actually use this. AWS has intentions to use it under their Lambda service. Again, this higher level of isolation for untrusted code coming from everyone's functions. gvisor, let's see how we're doing on time. Yeah, this is going to be tight. So gvisor. So again, I have, let me make sure we're not running any Nginxes right now. So again, I've used runtime class to set up gvisor as a selector. And so if I apply my Nginx example for gvisor, I should see that that is creating. And again, this is using gvisor under the covers, again, using its Containerd shim to start that process. And as long as everything works, we have a running Nginx using gvisor. And again, I believe we can exec into that pod and verify that. And you actually see a nice little message starting gvisor and some funny messages from the gvisor team to prove that this is isolated by gvisor. Again, a lot of information out there about gvisor. It's using this kernel written in user space concept. It's written in Golang. If you've heard of Google Cloud Run, it's actually using gvisor as this isolation security boundary for that. You can use it standalone as an OCI replacement, and again, they have the shim that we just demonstrated. And again, they're reducing syscalls that are using the real host kernel, and your application is being sort of routed through their user space kernel. Some applications may not work if they haven't implemented the syscall yet, and there's a lot of good detail online from their team. Again, there is a KVM mode that may win back some of the performance loss of capturing your syscalls and getting them through gvisor. I don't think I'm going to have time to demo Singularity. Singularity, again, is a high-performance computing runtime that initially wasn't OCI compliant, nor did it have a CRI, but in the last few months, they've added those capabilities. It's not daemon-based. It sort of has, again, it fits this HPC model of sort of end-user workload scheduling. So a big national lab, scientists submit their jobs via sort of a login node, and so Singularity matches that model well. And now they have a CRI, again, with interest in Kubernetes in the HPC community, in the science community. So if you were here earlier in the week, you saw folks at CERN demonstrating using Kubernetes in their experiments. So again, Sylab has seen that same interest, and so they have a CRI. I don't actually have it set up as the CRI runtime for a Kubernetes cluster. Again, just lack of time and ability, but I am running their CRI runtime here. So again, it's listening on a Unix socket. If you told kubelet, go talk to this socket, and then deploy to pod, I actually do have it set up with cri-CTL, and so, you know, I could, you know, we do have the ability through cri-CTL to run a pod. So again, I'm not using the Kubernetes API, I'm just using the CRI API, and so I can run Nginx, and you'll see that, you know, the daemon got that request, did an OCI create of a container. Again, I said I wasn't going to demo Nabla. We're already very, very close to time, but this is another sandbox idea using unikernels. So IBM Research created this. It uses a very highly limited seccomp profile, just a few syscalls are allowed, and then the unikernel is compiled with your application. One of the drawbacks is then that you actually have to use their Docker Hub-based base images because they're already linked to these user unikernel libraries. So again, IBM Research is trying to remove that limitation as we speak, because obviously that would be one that we couldn't use the same Nginx image we've used in all these other demos. So again, just finalizing, the OCI has gotten us to a place where we have this common underpinning that allows innovation, but yet have interoperability. We didn't have to change container images to use all these different runtimes. CRI has given us that same kind of pluggability in Kubernetes, so we can use all kinds of different runtimes under Kubernetes. And then runtime class gives us additional flexibility to, within the same cluster, have, you know, lots of different uses of different sandboxes and default Linux-based isolation. So with that, I'm going to say thank you. I think I've barely kept within the time. And if you have questions, I'm around the rest of the day and be happy to answer them. So thanks for coming.